let us look at transition dynamics in Solow model. We have seen that at the steady state, capital per worker is not growing. That is what the meaning of steady state is, that capital per worker is not growing. So here at this point, this is what my steady state level of capital per worker. But here K dot is equal to 0, right? So K dot by K is equal to 0. So the way you have found out steady state is by putting K dot equal to 0. So the moment you put K dot equal to 0, so this small K dot by small k, that is also equal to 0. That means the capital per worker is not growing. Small K dot is instantaneous change in K, small k. Small K dot by small k is growth rate in small k. So capital per worker is not growing in steady state. So one thing is that. But what is happening in off steady state position? When you are not at the steady state, that is what we are interested in, right? So there can be growth when you are below steady state, but then the moment you reach at steady state, the growth is going to be halted, right? So in this model, economies may grow for some time but they can't grow forever, right? So if there is an economy which has still not reached its steady state, it will be experiencing growth. So while transiting towards steady state, it will experience growth, right? But the moment it reaches steady state, then the growth is halted. But that is what we are interested in. What is happening when economy is not at steady state? That is what we are interested in, right? So an economy that begins with a stock of capital per worker below steady state value will experience growth in small k and small y along the transition path. I'll be telling you what that transition path is. Along the transition path, right? Now, this is along the transition path. Transition path to what? To the steady state. To the steady state, right? So the further away you are from the steady state, more growth you will experience. Closer and closer you are going to reach towards the steady state, growth will be lower, and the growth is going to completely halt it will be stopped the moment you reach steady state. Over time, growth slows down as the economy approaches its steady state. And eventually, growth stops altogether. So we'll go back to our key equation of Solow model. We'll go back to our key equation of Solow model, which is what? Small k dot equals to S small y minus n plus delta small k. So this is small k dot S, but you have already derived earlier in the earlier recording that small y is output per worker, which is equal to small k to the power alpha. So if you have not seen those recordings, please do that. Minus n plus delta small k. Okay. Achha, this is instantaneous change in small k. If I want to write the growth rate, so can I divide both the sides by small k? I can. Small k dot upon small k is S into small k to the power alpha minus 1 minus n plus delta. This small k will get cancelled out. This small k will get cancelled out, right? So this is what we have. So this is the growth rate in capital per worker. This, so I'll just write it somewhere. This small k dot by small k is nothing but the growth rate in capital per worker. Achha, the way capital per worker is going to grow, it will have the proportional change on the output per worker also. Why? Because I hope you remember this, that small y is equal to small k to the power alpha, right? I can take log of both the sides. So it is log small y equals to alpha log small k. I can do it this way. I can take the time log derivatives. D log small y upon dt equals to alpha d log small k upon dt. So this thing is what? 1 upon y, 1 upon small y into d small y by dt equals to alpha 1 upon small k into d small k by dt. We can write like this. So what is d small y by dt? Small y dot upon small y. So alpha. What is so d small k by dt? Small k dot by small k. So what I'm trying to say is that whatever is happening in growth rate of capital, that is proportionally affecting the output per capita also. This is also you need to understand this. So what is the meaning of this point? This point means, can I just... The meaning of this point is that the growth rate of small y, that is output per capita, is proportional to the growth rate in capital per worker, right? Growth rate in small y is proportional to the growth rate of small k, right? So the way, I mean, whatever you say about small k, you can easily say almost the similar thing about small y also, because the growth rate of small y is proportional to the growth rate of small k. Fair. Achha, then you think about it this way. I'll just rewrite this equation because I'll be needing it. That is small k dot by small k is equal to s small k to the power alpha minus 1 minus n plus delta. I hope you are not in a hurry, because I am not in a hurry, right? So these lectures are not in any way, in any kind, quick fixes. So you will have to sit with them. I'm assuming that you are writing alongside, you will understand it more. I can just assume and I can just advise you that it'll be helpful for you. Okay. Acha, other thing is, alpha is lying between 0 to 1, so it is less than 1. So let's say you have alpha is half, right? Or anything. So it is going to be what? Say alpha is equal to half. So alpha minus 1 is equal to half minus 1, that is minus half. So small k to the power minus half, it will be something like 1 upon root, something like this, right? So the idea is that as your capital is going to grow, capital is going to increase, capital is going to grow, then the growth rate of capital will eventually fall, right? It is going to eventually fall. So please write this. Because alpha is less than 1, right? As k rises, as small k rises. So be very particular in Solow model, whether you are saying small k or you're saying capital K. That is important for us. Small k, as small k rises, the growth rate of small k gradually declines, right? Growth rate of small k gradually declines. So you look at this thing. So this is the first term, this is the second term. As your small k is going to increase, this term is going to grow, is going to fall, right? As your small k is increasing, s is given to you from outside. So you have the first term is s into k to the power alpha minus 1. This is the first term, right? Or in simple words, don't write this. Let's say if alpha is equal to half, then it is s upon root k, like this. So s is given to you from outside. It is exogenously given. And as small k is going to increase, this is eventually going to fall. This s upon root k, this is going to fall over time. Please write. And the higher the level, of capital per worker, point. The lower is the average product of capital. Small y by small k. Now, what do you mean by this? How is this coming? Okay. Beta, you remember this? We started with this. Yes. This was a production function initially in our initial recordings. Yes. Okay. Then this is what? K to the power alpha, L to the power 1 minus alpha upon L. So this is what? This is your K to the power alpha into L to the power 1 minus alpha minus 1. Into L to the power 1 minus alpha minus 1. So this is what? Capital K upon L to the power alpha. So that is small k to the power alpha, right? This guy is small k to the power alpha. So this is what? Small y is equal to small k. Small y is equal to small k to the power alpha, right? Fair enough. Okay. Now, if I'm going to divide this, and this is what? This is my average product of the labor, right? But I want the average product of capital. So average product of capital. So that is k to the power alpha, L to the power alpha, into L to the power 1 minus alpha upon this. So this is going to be what? K to the power alpha minus 1 into L to the power 1 minus alpha. So I can write this as K to the power alpha minus 1 upon L to the power alpha minus 1. So this is capital K by L to the power alpha minus 1. So this is going to be small k to the power alpha minus 1. This is going to be like this, right? Small k to the power alpha minus 1. Fair enough. So this is my average product of capital. That is y by k is small k to the power alpha minus 1. Okay. Now, can I divide both numerator denominator of this with L? I can, and it doesn't change anything. So what does this thing become? Capital Y by L, small y. What does this thing become? Small k, capital K by L, small k. And this is equal to your small k to the power alpha minus 1, right? This is equal to the small k to the power alpha minus. So this guy is nothing. Your AP capital K is nothing but capital Y by capital K. And you're writing it in this way. So what they are saying is that if you look at it, this small y by small k, don't be confused. The small y by small k is nothing but capital Y by capital K, which is nothing but average product of capital, right? So, and this small y by small k is nothing but small k to the power alpha minus 1, which is this. And what you are saying is that as you are using more capital per worker, right, the average product of capital is going to fall, which is true. And this is true because of diminishing productivity of the capital, diminishing returns to capital accumulation. So please write this: because of diminishing returns to investment. Because of diminishing returns to investment. So this is the first term. This guy is the first term. And then you have the second term. Second term of what? Second term of this expression. So you have decoded this term. Now let's decode this term, which is n plus delta. There is no k here. There's no problem at all, right? So it is, this is the second term, n plus delta. It doesn't it does not depend upon small k. It does not depend upon small k. Now comes your diagram. Just have a look at this. So you have small k on the horizontal axis. And this is this line, n plus delta. This is nowhere dependent upon small k. And here you have investment per worker or growth rate in capital, whatever. And beta, this is your first term. This guy, which is what? Small s into small y by small k, which is small s into small k to the power alpha minus 1. This I have told you now, that as your small k is increasing, this term is going down. Your y, small y by small k is going down. S is exogenously given. So s, small s into small y by small k is going down. This is right. As your small k is increasing. This is what you have done. And at this particular point here, this is at this point, this thing is equal to this, means small k dot by small k is equal to 0. Beta, this is this expression now. Small k dot by small k equals to s into small k to the power alpha minus 1 minus n plus delta. So when these two are equal, that is the point of small k dot by small k to be 0. So that means what? That means your steady state. That means the growth rate in capital per worker is 0 here. This is that point. Small k star. Now the point is that supposedly you are sitting here. Tuck, tuck, tuck. Here. So what is the growth rate? Here. The growth rate is small k dot by small k. Is this growth rate more? Or is this growth rate more? You can say this is the growth rate at when capital per worker is K1. Or is this growth rate more? This is which growth rate? Small k dot by small k, let's say 2. So this is small k1, this is small k2. Now you tell me one thing. Further away you are from the steady state, more you are growing. The nearer you are going towards steady state, the less you are growing, right? And the moment you reach towards steady state, growth is halted. Is that right? So, right. So the difference between the two lines is nothing but the growth rate. That's what it is. This is, you have drawn, this is the first term, this is the second term. The difference between the two lines is nothing but the growth rate in capital per worker. So the further, please write this line, the further an economy is below the steady state value of small k, the faster the economy grows. The faster economy grows. You with me? So the growth rate in capital per worker at K1 is more than the growth rate in capital per worker at K2, at small K2, right? So the further you are away from the steady state, the faster you are going. The nearer you are to the steady state, the lower you are going. You with me? The further an economy is below its steady state value, the faster it grows. And the further economy is above the steady state value, the faster it declines, right? So for example, you are here. So here the growth rate in decline, because now you will be moving towards it. So here you are moving towards the steady state. From here, you will be moving towards the steady state from the right hand side. So there is the fall in the growth rate here. There's the fall in the growth rate here. So the further you are above the steady state, the faster is going to be the decline. Also, the further an economy is above its steady state value of small k, the faster small k declines. The faster small k declines. So this is your transitional dynamics in Solow, right? I hope you would have made notes and I hope you liked the video, right? Thank you, Beta.